Okay, this is question 7 from January 2022, P4 paper. Let's have a look at it. It's a volume of revolution question. We can see that we've got this area here, which is being rotated around about the x-axis. We're going to end up with this sort of shape here, which, as we can see over on this side, is supposed to be some sort of doorknob. So volume of revolution about the x-axis. So let's get started with it. Part A, volume of revolution is equal to the integral of pi y squared dx. Generally we take the pi out. It's the integral between 4 and 0. Y squared then is going to be a quarter 4 minus x e to the x all squared dx. So that's pi, a quarter squared is 16. I'm going to take that out of the integral. And then 4 minus x all squared. And e to the x times e to the x is e to the 2x. We add the powers, and then tidying that up is pi over 16 between 4 and 0. That's going to be x squared minus 8x plus 16 e to the 2x dx. And I'm pretty sure, yeah, that's what we're actually trying to do in the first place, was to get that. So we've proved that. On to part B, and in that case obviously k was pi over 16. Part B, find the exact value of the volume, which in other words means trying to evaluate this. And they're going to say to me, get it in the formats p pi eq plus r. Well, yeah, that's a little bit beyond me at the moment. I'm not worrying about that too much. Let's just get started with actually doing it. Later on we can have a look and see what that's going to be. So if I'm going to be doing this question, then one of the things that I am noticing is that I've got this pretty much of the format x squared e to the x dx. I recognize that as being integration by parts, and not only do I recognize it as being integration by parts, but I know that when I do the first iteration of it, I will still be left with x e to the x, and I'll have to do integration by parts on that one to then have something of the format e to the x's, e to the 2x's obviously. But yeah, okay, got a game plan then before I get started with this question. Let's actually have a go at doing it. If I'm going to do an integration by parts question, what I always tend to do is to write down the formula for myself just to make sure I'm not making any silly mistakes as I'm going through. Integration by parts is that u dv by dx works out to be uv minus the integral of v du by dx. So in this particular case, I've got u is x squared minus 8x plus 16, and I'm going to get du by dx from that then is going to be 2x minus 8, and I've got that dv by dx, that was equal to e to the 2x, which is going to give me v then as being the integral of that, and the integral of that is just going to be a half e to the 2x. So what that means is that the volume I want is going to be, well, first of all, we've got pi over 16 outside of it, haven't we? And then uv is going to give me half e to the 2x, x squared minus 8x plus 16. All of that is between 4 and 0. I actually say VU rather than UV, but just so that it looks a bit neater. Minus the integral of V du is going to give me a half e to the 2x times 2x minus 8 dx. Okay, make sure that minus is clear. We need to be really careful about our working out now. What I'm going to do is to try and do that one first of all. That's between 4 and 0. And then once I've got the answer to that one, come back to this whole version here. So let's make it really clear. I'm going to try and work out what the integral between 4 and 0 of half e to the 2x minus 8 dx is. And again, obviously with this one, I'm going to be doing integration by parts again. Okay, so this time I've got u is equal to 2x minus 8, which means that du by dx will be equal to 2. And I've got that dv by dx is the same as it was last time. Well, no, I suppose it's half e to the 2x, but it's the same technique. Integrating that is going to give me a quarter e to the 2x. Okay, so when I'm putting that into uv minus v du by dx, I'm going to get uv, which will be a quarter e to the 2x minus 8. That's all between 4 and 0 minus the integral of v du, which is these bottom two, which is 2 over 4 e to the 2x half, but I'll leave it as 2 over 4 just for the time being, just making it clear to the examiner what I'm doing. But then I'm going to tidy all of that up. So that's a quarter e to the 2x minus 8, and then I'm actually going to just be able to integrate this pretty quickly. The whole point about doing that, it's half e to the 2x, and if I'm integrating half e to the 2x, we've done it loads of times before, it's now going to become minus a quarter e to the 2x. So all of that then now that I have integrated, that's all between 4 and 0. What I need to do with this bit now is that this now needs to go in place of that bit there, okay? And when I do that, I do need to be careful about that minus in there. So as I said, a real concentration level on when we're doing this. That's going to work out to be that my original part was going to be pi over 16. Right, so it's a half e to the 2x, x squared minus 8x plus 16, and then it's minus all of this, so it's minus a quarter e to the 2x minus 8, and then plus a quarter e to the 2x. All of that is going to be between 4 and 0. Now, I'm going to need to have another page here, so give me a second while I just copy that page, paste it in, and then now I've got that. Let's just give me a clear page here. Give me for 1 second. Okay, so back to the work. Apologies that. Right, so now in tidying this up, you know, we do want to see if we can try and get the final answer here. If I want to get the actual answer, I'm going to try and make things a little bit easier for myself, even if it's a bit slow. So I'm actually going to take e to the 2x out of all of this. I'm going to take it out of here, here, and here, and I'm going to try and tidy this all up to make it some sort of algebraic expression, some sort of quadratic probably, that's just going to be a bit easier to work with. So I've got half x squared, I've got half of 8x, which is 4x, I've got half of 16, which is 8, I've got 2x over 4, so that's x over 2, I've got the minus and the minus 8 there means it's going to be a plus 2 plus a quarter, all between 4 and 0. Now you could choose to put your value straight in there. I'm not going to. What I'm going to try and do is make it pi over 16 e to the 2x, and I want this to be one single function here, which I'm virtually at anyway. So it's x squared over 2. Combining those x's gives me minus that 9x over 2, and combining the constants gives me that, all between 4 and 0. And now I'll put my values in. So hopefully this will pay off in a second. Sorry, that should all be, give me a second. This bit should still be with the e to the 2x inside it, obviously, shouldn't it? Okay, so brackets there, apologies there. And again, same thing here. Just move that over. We're still evaluating that one. I just wanted to make it a bit easier to actually do it. So now if I put 4 in, I'm going to get pi over 16 e to the 8, and I'm going to get 16 squared over 2, so that's 8. I'm going to get 9 lots of 4 over 2, so that's 18, plus 41 over 4, minus pi over 16 e to the 0. Be careful, that's not 0, but the only value of all the rest of it will be the 41 over 4, because the rest of it will have gone there. So if we tidy that up, actually working out e to the 8, and then this bit here, do it on your calculator, all works out to be a quarter. So I get pi e to the 8 over 64, and the other bit is minus pi, again it's over 64, just 41 there, which finally tidies down now into pi over 64 e to the 8 minus 41. And if we go all the way back to the question there, we've now got it in the format that we wanted there to be able to do it. Very long question. Don't worry if you can't get all the way through it. I mean, obviously, under exam conditions, that's really tough to get that absolutely 100%. But some of the concepts there are really important. Okay, hopefully that makes sense.